Example 7, Chapter 5. Saturated vapor of 134A saturated vapor is contained in a piston and cylinder. The system at temperature room T equals to 20 degrees centigrade, at which point the cylinder volume is, and V equals to 10 liters. Which is equals to meter cube. The external force restraining the piston is now reduced, allowing the system to expand. So we can name this point state 1 and state 2 the pressure decrease, or force restraining the piston is now reduced. Allowing the system to expand to V second liter. We will consider two different situations. A. The cylinder is uninsulated. In addition, the external force is reduced very slow, so we have quasi-equilibrium. If the work done during the process, W kilojoule, how much is heat transfer? Q is on. Now, and for B, the cylinder is isolated. The external force is reduced, quasi-equilibrium, rapid motion. Causing the process to occur rapidly such that the final pressure is set. The pressure the cylinder is P. What are the heat transfer and work for this process? W and heat. This is the problem number 1. For this case, we should at first specify the state 1 and state 2 for each section. Solution of part A, state 1. We have superheated and we should use the table number table B4.1 for saturated vapor of R134A, B4.1 for the superheated vapor, saturated vapor. Let me make a correction here. Saturated vapor. We can extract the information in this point. For this temperature 20 degrees centigrade, and also B 10 liter meters cube. For this point we have this information. P1 equals to Pg or P saturate is 1444 kilopascal, this quantity, and also we have V equals to Vg because of the saturated vapor. U equals to Ug it is R for we should change the table. So I changed the table. We should use R134A for 20 degree. We have pressure and Vg as the saturated vapor specific volume, and the internal energy is in this case we can calculate M equals to V on Vg M equals to kilograms. At second, it said that state 2 we have B2 equals to 40 liter, 40 multiply so as the same mass we can write V1 on M1 equals to V2 equals to V second equals to V MV2. So V2 equals to, we have M at the point second and also V. The second position specific volume is obtained. Checking with the in this ratio, the process implies in addition extra possibility as the process takes place. If the work done during the process is how much? In state 2, we have also the temperature 20 degrees centigrade because it is happening in the room temperature, and the end of the state is the process is going to a constant temperature. Work given, and W is kilojoule. At the T equals to 20 degrees, we have Vg, V second greater than Vg, or other words, greater than. So we have superheated process. In this case, we can calculate the from B5 to as table shown here. We should first find the pressure, which can give us the specific volume at the temperature 20 degree near this quantity. The table shows the pressure for in a work given process and temperature constant. We have to find a pressure in superheated form tables at temperature 20, where the volume is near VUHS, or between near these two quantities, or between these quantities. With the interpolation, we have a relation for the interpolation at P V P V is and P equals to 200, and we make the interpolation P minus P can be calculated and is kilopascal. From this relation and interpolation, we can also calculate as the same U. In this part, we can use U, and U is at the second point. Interpolation between the internal energy and for example, a specific volume. The quantities are very close to each other, so the U second is obtained as this quantity. To calculate Q, we should write First law delta U, U second minus U1 . U second is 2 times 10 to the minus 2 U1 equals to Q minus 3 kilojoule. WAT, it is plus work on plus work out or leave. M that we calculated before, M is this quantity multiply U second minus U1 so the kilojoule for the part 1. For the part 2, rapid process, P second for isolated we have Q equals to 0 and the more state 1 is now from previous with the information about U1 equals to and temperature, pressure also known and is kilopascal. State 2 is as shown, P second V2 also now and is V on M we should use the table B51 first to determine the state. It is greater than Vg as previous. For the pressure 105 kilopascal we can bring the table. Now we should first calculate at the pressure 150 a quantity between 2. We should first calculate V G equals to and P equals to, we have Vg equals Vg can be calculated and is from this relation. Let me write Vg minus should be equals to this subtract with mechanical simplification. The relation is with mechanical simplification we can obtain Vg as the quantity of at saturated pressure. It will be greater than Vg, so we have superheated. Superheated is for we should read the pressure for V equals to the table is provided here, table B 5.2 for R. In this case we have to obtain a V at T equals to 0, we have V as T and at T we have we should also write U VUHS At first, we should write the interpolation between these quantities, and next we write a interpolation between this quantity and obtain T equal and U for superheated vapor. For the first law, Q also equals to 0, so we have W minus delta U M U second minus U1, or M U1 minus U second. U1 is calculated and U second obtained W work illusion. Working with table, so easy. If you have a formulation, for example, a scientific engineering calculated or an application for calculating the interplate relation between the various quantities.